Okay, welcome to this series of overviews and educational videos or updates and on the Cisco's Catalyst SD-WAN Manager. And this focuses on our industrial routers, industrial IoT routers. And in this session, we are going to focus on troubleshooting and monitoring. For that, we want to quickly take a step back, refresh our memory on how we onboard a device, how fabric formation works for SD-WAN, especially taking the context of industrial routers into the system. And then we'll give you some data points, or we'll show where some of these failure points are. And then we'll talk a little bit more detail about how to monitor and troubleshoot live on the SD-WAN Manager tool. So a quick refresher on how PNP works, basically onboarding a device into the SD-WAN Manager. So the first step is once we've added the industrial router into the PNP portal or our software.cisco.com account, that list should be synced with our SD-WAN Manager or uploaded to the SD-WAN Manager. Now, once the router is powered up, the first thing it's going to do is connect to the PNP server, which is devicehelper.cisco.com. And it's going to pull down a couple of things based on how we've configured the PNP Smart account. So the first thing it'll do is pull down the validator. That's the validator here. We'll pull down the validator hostname or IP. It's going to get the org name for certificates, for certificate validation. And if you have multi-tenancy, then it plays a role there as well. And if you have a trusted CA certificate, it's also going to pull that here. So that's the first thing. Now I'm going to clean this up a little bit, just to keep it a little bit neat and clean. So step 2 is now the industrial router knows that it has the host name or the IP address of the validator. Now the validator is the device that acts as the proxy for onboarding devices. It helps with the dissemination of information for how the edge device, or in this case the industrial router, should connect to the controller or the manager, so it provides that information. And it also acts as a NAT traversal agent. If there is a NAT boundary, then the validator can discover those NATing agents and use that information to help build tunnels or data plane tunnels through those NAT boundaries. So basically, the validator is the gatekeeper for the first onboarding of the device. So the first thing the industrial router here will do is it will build a DTLS connection to the validator. The validator will check the certificate on the industrial router that it's a valid certificate, or check the organization name of that certificate. And once it validates the certificates are correct, it's going to form a DTLS connection. Now, once the DTLS connection is formed, the validator is going to check with the SD-WAN manager that this device has been uploaded or is a valid list device in the list of devices. So that would be step 3. Step 4 is the validator will send down the IP address of, or the host name of the manager. So now we know how to connect to the SD-WAN manager. And so let me clean this up a little bit again. Now step 4 is create a DTLS connection with the SD-WAN manager. And that's step 4, right? So far, we've been allowed onto the network, the SD-WAN manager. We formed a DTLS connection with the SD-WAN manager. Now, the SD-WAN manager sees this, and hopefully we've prepared configuration templates, or we should, before we even get to this step, we should have prepared configuration templates or configuration to put down to the router. And step 5 is config push from the manager to the investor router. So in this config push, we're going to get a few things. We're going to be, the main thing we will be getting is the controller IP or hostname. We've also configured through the configuration mechanism or templates, the site ID, the system IP, that's been pushed down to the router, right? So now it has a site ID. Let's give it site 100. Let's give the controllers a site of 1, site ID of 1. Let's give this a system IP of 192.1.1.1. So that's the system IP. That's the site ID. Site ID of 100, system IP of 192.1.1.1. And the controllers have a site ID of 1 and a system IP of 1.1.x, and basically 1.1.1.123, depending on how you want to create the IP address or site ID system IP notification for the controllers, right? So yeah, let's give this 1.1.1, let's give this 1.1.1.2, and this will be 1.1.1.3, right? So those are your system IPs for the controllers, which we really don't need at the moment, but they'll play a role later. So just to add, the way the system IPs play a role is the DTLS connection is formed with the system IP of the controller, right? So in this case, the second or during the 4th step, we formed a DTLS connection with the manager, and this DTLS connection was formed using the system IPs of the manager and the edge device. So now we have that basic information, and we now know one of the main pieces of information, which is the controller hostname or the IP address. And at this point, we'll start with the fabric formation piece. Okay, so let me clean this up a little bit so that we can now get to the interesting piece, I would say. So now in step 6, we know the controller information, we know how to reach the controller, and in step 6, we are going to form a DTLS session with our controller. So we still have a DTLS session with the manager. I just removed that for the sake of clarity, but we still have a DTLS session, permanent DTLS session, using one of the WAN interfaces with the manager, and then we have a DTLS session with the controller. Our DTLS session with the validator has been removed because that was only needed for the onboarding stage. So that is a temporary connection that is brought down. So now that we have a control connection with the controller, what are the next steps? So if you notice, we still haven't connected to our other routers in our network or our other edge devices. So let's see what's happening there. So we have our underlay or service provider network. So that's our service provider or our underlay network. Again, let me clean this up a little bit. So this is how the routers, have communication or connectivity with the other routers. So we call that the underlay. So that's our traditional routing, right? So we want to build an SD-WAN fabric or overlay on top of this. So how does that happen? So we have two transports. We have, as you see, we have an LTE tower here. So we have an LTE transport, and then we have maybe a fiber or copper connection here. So we have, let's call this an internet or iNet transport. So this is the LTE, and this is the iNet. iNet, let's call that the connected or wired transport. Right. So we have two ways to reach the internet. Right? So we've already built using either the LTE or basically whichever transport came up first or was configured during the PNP process. That's the transport or the global routing table or the global routing that we used to connect to our PNP server, to connect to create DTLS sessions with controller, our manager, and so on, right? So we've already done that, but we still haven't built a data plane fabric over our underlay, right? So how do we do that? Now, during the onboarding stage, we also defined which transport, or during our configuration, we should have defined which transports are going to build an overlay or SD-WAN tunnels. And these are essentially IPsec tunnels that will be built over the underlay network. So let's say we define two transports I've shown here. We define the LTE and we define the internet transports. And what's going to happen is we already have a DTLS session with our controller. What our controller is going to do is this, we can call this step 6, I guess, is going to send down keys. So it's going to send down keys for tunnel creation. And it's also going to advertise some information that we will get into a little bit later. But it's going to send down keys. And what's going to happen is it's also going to send down what's known as a transport locator or a T-lock. So it's going to send down a T-lock to both IR1 and IR2. So a T-lock is your system IP, site ID, and the transport. So your transport is labeled, we call that label a color. So we have a color for LTE and we have a color for iNet. So your T-locks are advertised. So we have T-lock from the IR, which is IR2, that's sent down to IR1. The T-locks from IR1, which are LTE and iNet, are sent from IR1 through the controller. The controller reflects it back to IR2. So now each of these IRs or the edge devices, the routers, they know how to get to each other, right? So they know that for LTE, this is, let's call this T-lock 1, let's call this T-lock 2, let's call this T-lock 3, and T-lock 4. So for IR1 to reach T-lock 1, it knows it has to go out of T-lock 3. And so that's T-lock, again, reminding you again, is nothing but a combination of the site ID, system IP, I take that back. It's a combination of the system IP encapsulation, which is IPsec, and the interface label, which is LTE, or we call that the color in the context of SD-WAN. So it knows how to get to IR2 because the controller has advertised all of these T-logs to the IR1 edge device. Now, we know this information now, but we still have to build a fabric, right? So the controller is now going to exchange keys which will be used for encryption, for IPsec tunnel formation and encryption. So the first thing it's going to do is it's going to exchange or send out keys for these creations. And note that during this process, none of this exchange is taking place directly between the edge devices. All of the control information or the keys to formal tunnels or advertisement of the next hop information, all of that has been done through the controller, right? So keep that in mind, and this is what we mean when we say that we have control plane and data plane separation. So we have the T-logs now, and now we have the keys. So at this point, we have reachability between T-log 1 and 3 and T-log 2 and 4. We may also have reachability between T-log 1 and 4 and T-log 2 and 3, right? So, and at this point, we are going to build an IPsec tunnel between IR1 and 2 over T-log, or the LTE T-logs. We're going to build a tunnel between IR1 and 2 over the internet or INET underlay. We could also build a tunnel over the so let me clean this up a little bit again. So by this point, we should know what the underlay is, and so we have, let me create the T-logs again. T-log 1, T-log 2, T-log 3, T-log 4. So we can form an IPsec tunnel over the underlay between T-log 1 and 3. We can also form it between T-log 1 and 4. If we have reachability, that is, if these are public networks. If they are private networks, then they don't have reachability, the tunnel will never form. We can do the same thing with T-log 2 and 3 and T-log 2 and 4. So essentially, we have 4 IPsec tunnels side to side between these edge devices. So now we form the tunnels. What happens next? How do you know these tunnels are healthy? Now we formed the overlay or the fabric at this point. How do we know these tunnels are healthy? How do we use that information to route applications and so on? So the controller will configure, or the controller will push down rather configuration through help from the manager for BFDs. So bidirectional forward detection, those are packets that are sent over these tunnels periodically, and they monitor the health of the tunnels. So the things they monitor are latency, jitter, and packet loss, right? So BFDs are liveliness packets. They are sent every so often, depending on the frequency configured through the SD-WAN manager. And really these are the key things that are helping you determine how healthy a link is, right? So if the only link that if you define a link to be healthy based on policies that we will also get into later, but if you define a link to be healthy based on 1% packet loss, and these are 2%, 4%, and 10% of packet loss, this is the only healthy link, right? And that's going to be the link that will be used to send mission critical applications and data. So essentially now we've transformed our underlay, which is probably not as equipped to see all of this from a bird's eye view of the controller, and we've transformed that into an overlay which the controller has full visibility into, which the manager has full visibility into, and we can now use this for our SD-WAN fabric and management systems, especially for monitoring the link. So for making sure that these links are active, making sure we're sending down traffic to through these specific paths, and also for WAN redundancy, right? So if ever you have, disconnection, you have the LTE network go down. Let's say you lost your LTE connectivity, so you lost these WAN links. So you still have reachability from the iNet to these, right? So you would start rerouting traffic, and these are both in active state. So you will immediately start using your TLOCs that are associated with the iNet transport and basically connected or fiber or wire transport, and use that for forwarding packets of data. So, all right, so what are the other failure points in the system? And how does your OT network play into this whole system, right? So we formed tunnels now. So let me clean this out again. And this is the last stage, and it's probably of interest to us as well. But let's redraw the TLOCs again. For the sake of clarity, I'm just going to draw two data tunnels, just for clarity. Okay. Now we missed a very critical part, and that was intentional because this is really the focus, or where edge device and IT and OT convergence comes into play. And that is our service network, right? So, and how does, let's say you have a PLC or an RTU or some asset connected to one of the edge devices, and we have let's take a utility use case, for example. We have a SCADA server on edge device 1. How do we make sure PLC or RTU, that's an IP PLC or RTU, and we see it as well, but if it's an IP reachable controller, how does that reach our SCADA server? So this is where one of the key concepts of the fabric routing protocol comes into play. And the way we were talking about TLOC before, how does the controller advertise TLOCs? It's through the protocol known as the overlay management protocol. So the overlay management protocol does a few things, but the key things that it does is it advertises TLOCs, it advertises what's known as the service network, or the network behind the IR, and it also advertises any firewalls or any other types of services in the network, right? So OMP is the control plane protocol for the fabric, and this behaves very much like BGP or a route reflector, but it has additional capabilities such as policy and control information that is sent down through the protocol. So let's go back to our PLC or control network here. Our service network here is sitting here not having reachability to the SCADA IP. So our service network, let's call it 192.168.2.x, right? So the slash. How do we advertise this network to the IR? And let's call this, 172.110.10.1, right? That's the SCADA server IP network. And let's call the PLC network as 192.168.2.10, right? Slash 24. This is the slash 24. So at the moment, we don't know how we will have reachability between these devices, but that's where OMP comes into play. OMP will detect these service networks or service subnets, or we can call them segments. So these are, let's call this segment 1, right? So this is again segment 1. So the segment is nothing but a VRF. So this is VRF1, right? And OMP is the transport network is VRF0, which is nothing but VPN 0 or our global network, right? So our global routing table, our global network is the default VPN 0, VRF0, whatever you want to call it, but that's not segmented. We have these segments that are part of the in the SD-WAN industrial router, and these VRFs have a specific network assigned to them, and have specific networks and interfaces assigned to them. Let's make this a VLAN interface. So it's connected to the PLC is connected to a specific VLAN, and that VLAN is part of our VRF. So now we're going to take this network, which is assigned to this VLAN 1, let's say, and we're going to advertise this over OMP, right? So OMP is going to take that and advertise that network. And if we have other networks, if you have other VRFs, VRF2, 3, whatever you want to name it, if you have other segments, they will also be advertised through OMP to the other routers. The advertisement of the segments will also advertise the network. So now we have reachability from the service network on the IR side with the client side or controllers to the SCADA IP and vice versa, right? So that's how we establish reachability through the OMP. All right. So now we've established the whole fabric and how we have reachability between IoT devices and assets. What are some of the failure points, right? So the main failure point can of course be failure of your transports, right? So failure of the transports is pretty solid, pretty reliable, because if you have multiple transports, you can always switch between them, but you have a single transport, then that's a definite failure point, right? And you lose reachability to the controller, you lose reachability to the manager, and your data plane goes down as well, right? So that's one of the main failure points. One of the second failure points could be disconnection of your PLC devices. So circle those. So you could have disconnections or interruptions, service interruptions in your service VLAN or segments, and that will prevent these networks from being advertised to other edge devices. You could also have failure of the controller, right? What happens in that case? If your controller goes down, so there's a very elegant process that takes place. So we have a window of time, usually, depending on how we configure it, that the data plane or the routers will continue to function. They will continue to be reachable. Your packets will go through. However, any new device or any new device or IR is not allowed onto the packet, right? Because you've lost connectivity to the controller is down. No new IRs are allowed into the system because you will not be able to advertise their T-locks as we saw before. You will not be able to create a control connection with the controller to be able to advertise T-locks. So no router will ever know of the existence until the controller comes back up. So those are some of the key failure points, and how do we troubleshoot that is what we look at. We will also look at how to monitor all of these, right? So how to monitor our WAN interfaces, how to look at our topology, how to look at your service VLANs, your service networks, and then how to also configure specific policies so that you can do application routing through specific LAN or WAN interfaces.
All right. So before we jump into the GUI, let's look at the setup here. So we went over what the T-lock not numbering system. So we have T1, T2, T3, T4, and we have the controller. So the first thing that happened was we found the DTLS tunnels. We established an OMP connection for fabric routing. We established IPsec tunnels between the edge routers and BFD sessions for monitoring the health of the tunnels. We also established VPNs or segments, and through an OMP update, they were advertised across the fabric to the other routers in the SD-WAN network for both VPNs. And what we are going to do today or now is jump into the GUI, and we have a couple of devices connected to the edge routers. We are using smaller Raspberry Pis that are simulating operations or physical assets connected to the router. They are both connected on the fast Ethernet ports through the VLAN SVIs. We do have other devices connected, but we won't be using that for this purposes. So we have VPN1 and VPN2 as the segments that are being advertised. And let's look at what happens when we have reachability issues between a device or the Raspberry Pi connected on VPN1 to another one connected on VPN1 on the other industrial router. So we've logged into the industrial um, router network, and this is the SD-WAN manager. And what you can see here, the first page you will see is the site health, the tunnel health, and it'll give you an overview of all of the sites and the SD-WAN fabric through the tunnel health dashlet. It'll also give you WAN edge health and show you the health of the edge devices by showing you the CPU and memory usage. It will give you a snapshot of the transport health by showing you loss percent or the quality of links or WAN links between edge devices, and give you some statistics on cellular and application aware routing. So this one shows you what the best paths are for routing applications by latency, loss, and jitter. So let's look at these two edge devices. So I have two of these Raspberry Pis connected, and the RTU test is the Raspberry Pi connected on VPN1 to an IR. And what I'm going to do is, so I'm just going to try and access a web page or a web server through an HTML is serving an HTML page. And you can see that it does not have a route to host. Let's try pinging it. And it's unreachable. So you can see that at the transport layer, we have reachability issues as well as at layer 3. So let's jump into what the issue could be and go through a typical troubleshooting flow that you may encounter with an OT and IT person working together to figure out where the issue lies. All right, so going back to the SD-WAN Manager UI, we can see that we have the site health, tunnel health, the WAN edge health, transport health metrics. And as you saw in this diagram, you can see that the issues could be in multiple places. So we could have issues with tunnels or the data tunnels between T1, T2, and T3, T4. We could have issues where OMP is not established between the controller and the WAN edge. You could have issues where BFDs are not running so that you don't know whether the interface is alive or is dead. We could have an issue where we have VPNs not being advertised or VPNs misconfigured. So let's take a look at this one by one systematically and then look at how to troubleshoot a specific uh, flow, especially for an OT device that has lost connectivity. All right. So let's go into the site health, and now this is for all sites. We want to go into our specific site to see its tunnel health with the other edge route. Let's get the latest statistics. You can go into Tools, Rediscover Network, and this will get you the latest statistics of the edge devices in the network. You can select a specific edge device as well if you want to get statistics for that specific device. So as that's doing that, it's trying to get metrics from the device. It's trying to get statistics and inventory data from the devices, from the edge devices, and so on. So that'll take a few minutes. All right. So now that's completed. Let's go back to monitor overview and let's go back to our site. And let's look at the specific router that we have here. Let's go back to devices, site 22, 122. And if you go into overview, you can see, click on the tunnel health. And our server or the web server is sitting on a edge device called the hub. So let's look at the details on the tunnels for that connectivity. So let's search the table for hub. And we can see that both the tunnels on both our transports are up and active. So we don't have any issues with connectivity there. We have great latency and low loss and low jitter. So we shouldn't have issues on the transport side. And the health is determined through BFDs. So our BFDs are alive and kicking. Let's go into the devices page again. And let's look at the specific device now. Let's also make sure our interfaces are up and running, which they should be since we saw that the tunnels are active and healthy. We have cellular 0 and cellular 1 and cellular 3 here. We can click on those and make sure the quality of the links is okay. You can see that we've been sending traffic regularly on those interfaces. We can see TXRX, and that is transmitting and receiving packets on those interfaces. So really, this is just confirming what we saw before, and that our tunnels are active and alive. We have a new section called cellular, and that shows you cellular health for both our service providers. And you can see things like radio health, the bands, aggregation, and other interesting characteristics of the cellular network. Our T-locks that we talked about, those should be up, and BFD should be up. And you can see both the T-locks are up and active. We did see the tunnels between the hub device and the IR1101. So both those are active as well. We can select those specific tunnels and see our historic tunnel health. And you can see that filter that by loss, latency. Can even see if the tunnels were down by click on tunnel status. And the loss percentage. So this gives you a quick overview of the tunnels. We can look at real time to make sure that we have BFDs. And you can see the BFD sessions between the router that we just are that our Raspberry Pi is connected to and the other devices. So you can see that the ones between the router and our specific hub, we can check for those as well. We can make sure that our OMP advertised routes that we are advertising are 10-10-10 network or 11-11-11 network in this case rather. You can even see our OMP received routes. So we can see that we received routes from our service VPN for the 10-10-10 prefix. And this is coming from our hub router, which we were trying to reach to just now, which was, if you notice again, if we go back to the router, we were trying to ping 10-10-10-10, which is not reachable through our OT asset. So how do we check further? All right, so let's look at our control connections. Let's make sure control connections are okay. So we have control connections for both our transports to the two vSmarts, alive and well. So you can make sure that control connections are okay as well. If we want to get into deeper troubleshooting, we can look at troubleshooting. And we want to make sure there are no issues with our underlay. So our underlay or service provider network. You can click on that and select by color. Let's try to reach the hub router 11 or rather 12 in this case. I'm sorry, that's our hub. So let's look at LTE and then the hub. Remote color is LTE as well. Let's start an underlay discovery just to see if we have reachability through the service provider or our own internet. And you can see that we have reachability, and the way we are reaching it is through those networks and network routers in the middle. So we definitely have reachability. Let's go back into troubleshooting. So you can do pings. We don't need to do a ping because we know we can reach it. We've already checked the control connections. There, all of the control connections are well. And we've also checked the tunnel health. So we can check the tunnel health again through the troubleshooting page to our hub and using the LTE transport and just hit go. And this brings up the same page that we saw before, but this gives you a cleaner view of the tunnel usage. And you can see that in the last hour, the loss percentage has increased, but I don't think that should matter. Um, so where do we think the issue could be? Let's take a deeper look now. Let's go back to so we've checked the DTLS and control connections. We know that OMP is working because it's advertising routes. We know that it's has a control connection with the vSmarts and the controller basically. We know that the IPsec tunnels are running, that we have BFD sessions running on them because the tunnels are sending us, or the edge device is giving us information on loss latency and jitter. So our natural suspect is, the VPNs themselves, and really the connection between the VPN or between the segments and the router. So let's look at how we are connecting the Raspberry Pi to the IRs. Let's go back into the UI. So let's look at the real-time page again, and we can check if there is a VPN. There is no VPN. We can check for interface detail. All right. So the interface that I've connected this Raspberry Pi on is 11.11.11.1, right? So VLAN 1. And VLAN 1 is running and active, right? So, but we are still not able to reach the hub on 10.10.10.10. Let's look at the hub side. Let's go into real time again. Let's look at interface detail. And this real time tool is, again, really very handy for running commands as if you were on the router. So let's check if our 10.10 interface is up. Yes, 10.10.10 is up and running. And the VLAN would only be up if we have a device connected to it or if we have the physical interface active, right? So the VLAN would not be active if it didn't have any of those or meet any of those criteria. So now, we know that the VLANs are active. We know that the interfaces connected to the Raspberry Pis are alive and well. So that leaves us with let's go back. That leaves us with the VPN configuration. So the only other thing I can think of is that we've misconfigured the VPNs, or we've put the device in the wrong VPN, right? So, and really that's one of the key things here, that you want to make sure that we have communication. If you want communication between edge or your OT assets, you want to make sure they're in the same VPN. And we have two VPNs here. So let's take a look at that config. So between the 11.11.11 network and the 10.10.10 network. Let's go back here. And you can even SSH to a specific device. So let's use that this time around. Let's click on SSH terminal and let's pick my device. I can log into the CLI through this router, through the GUI. And you can see I can log in like as if I was on the router. And let's check the VPN configs. So to check that, you need to do a show SDWAN OMP routes. And we have VPN 1. Let's check them by VPN. So you can see that in VPN 1, we only have 10.10.10.0. we don't have our 11.11.11 network. So that's a definite problem. Let's check VPN 2. And there it is. So our 11.11.11 network, from which we are trying to reach the 10.10.10 network, is in VPN 2. So let's try and fix that. So and and the reason you are seeing all of the advertisements working, the transports working, was because we were missing something very, very minute, and that was because we don't have reachability between VPNs unless we expressly configure that. So by default, your VPN segments cannot communicate with each other because they are separate VRFs, as we saw before, right? A VPN is the same thing as a VRF, and there is no communication by default between VRFs unless you configure them that way. So let's change that to VPN 1. And to do that, we can go into configuration group. Okay, let's go to the config group and change a few things. Let's edit this. And we'll have to change our VPN interface to VPN 1. Edit feature. And our VPN 1 should be associated to the OT VPN. Let's hit save. And let's push these changes. Let's click on the site and deploy. And site 122, we should see the changes. Let's preview the changes and scroll down. You can see that our 11.11.11 network, which is on the VLAN 1, has changed from VPN 2 to VPN 1. And let's hit deploy. You can check the deployment status. That should be a quick change. And at this point, it takes a couple of minutes to push down the change. You can check on the router. You will see the configuration take place. And vManager has configured it and finish configuration. Let's log in to the OT asset again, and you can see that we can log in through it through VRF1. And let's try pinging 10, 10, 10. And we have reachability. And we can also access the web server if we've allowed the ports on our firewalls. Hopefully we have. And we don't need to go into the additional troubleshooting there. We're going to access the test.html page, and we are able to access our web page. Welcome to SD-WAN. All right, that should be it on how to troubleshoot the SD-WAN fabric and how to isolate issues in SD-WAN. And really, I showed you multiple ways, but there is it's quite straightforward. Again, we looked at the control connections, we looked at the OMP establishment, we looked at the transport or the data plane layer, the transport tunnels, that they were lively and healthy through BFDs. The T-locks needed to be active and alive for that, so they were also alive and up. We then checked the connections between the OT devices, the Raspberry Pi, and the IR, and the physical interfaces were connected. And then we isolated the issue down to the misconfiguration on the VPN. So we had one of the Raspberry Pis connected on VPN 2 instead of VPN 1. So really a lot of debuggability and troubleshooting capabilities directly through the SD-WAN manager. You don't have to ever leave that UI for troubleshooting if you have network issues, and a lot more to come in how you can troubleshoot this. Thank you.